Hi guys, today let us do a quick revision of the fourth module. We first looked into the ferrous metals. Well, these are metals which contain iron as their main constituent. Here we studied about the cast irons. Well, these are obtained by remelting the pig iron in a furnace by making changes to its composition. The cast iron can be of several types, such as the grey cast iron, which contains graphite in the form of grey colored flakes, white cast iron, in which the carbon, that is a graphite, does not precipitate, the malleable cast iron, where the iron carbide is transformed into graphite, and then the spheroidal cast iron, where the graphite forms small nodules or spheres. Then we studied about the steels, that is the tool steel, which is the steel used for the production of tools in manufacturing processes, and stainless steels, which is the steel which does not corrode or stain easily. We then studied about the non-ferrous metals, that is where iron is not the main constituent of the metal, where we studied about brass, which is an alloy of copper and zinc, and then bronze, which is an alloy of copper and tin or aluminium or silicon. Then we studied about aluminium, which is a silver white metal obtained from bauxite. Then we studied about ceramics, that is the materials which are made up of inorganic non-metallic components. Here we looked into some examples such as glass, optical fiber glass and cements. Then we studied about polymers. Well, these are the materials which are made up of the bonding of several monomers of a particular atom by a chemical reaction. Here we studied about the thermoplastics, which soften upon the application of heat and become hard upon cooling, and then thermosetting polymers, which permanently gets hard upon cooling. Then we studied about smart materials, which are the materials which are able to detect changes in the environment and respond to them in a predetermined manner. Here we studied about piezoelectric materials, that is the materials in which the applied stress will induce a voltage, the shape memory alloys, where the materials can undergo deformation and will return to their original shape and size upon suitable heat treatment, and also studied about the semiconductor materials, where the materials whose electrical properties will lie between that of conductors and insulators. Here they are further classified into intrinsic semiconductors, which do not have any impurities, and extrinsic semiconductors, which contain several amount of impurities. Then we also studied about insulators, which are the materials which do not allow electric current to pass through them. Then we studied about composites. Well, this is a combination of two or more dissimilar materials which do not dissolve in each other, although they form a single material. Then we looked into the classification of the composites into fiber reinforced composites, where the reinforcement is in the form of fibers, particulate reinforced composite, where the reinforcement is in the form of small particles, and laminated composites, where several layers of the material is held together by the matrix. We also looked into polymer matrix composites, that is the matrix is polymer resin material, and also the metal matrix composites, where the matrix is a metal or alloy, and also ceramic matrix composite, where the matrix is a ceramic material. Next, we moved on to the concept of joining processes. Well, these are the processes by which two or more parts can be joined together. First, we looked into soldering. Well, it is a joining process which is used for joining similar or dissimilar metals by means of a filler material whose melting temperature is below 450 degrees Celsius. There are different types of soldering, such as soldering iron method, in which a tool called soldering iron, which has a copper tip, is heated to provide the soldering action, torch soldering, where soldering is done using the heat provided by a flame issued from an oxyfuel gas, wave soldering, where a tank filled with molten solder is used by pumping a wave of solder at a predetermined height to the materials, induction solder method, where the heat energy of the induced currents due to the varying magnetic field is used for soldering, the resistance method, where the heat generated by the electric resistance of the materials is used, and then ultrasonic method, where the heat obtained from the ultrasonic waves is used for soldering. Then we looked into the process of brazing. Well, brazing is a method of joining similar or dissimilar metals by means of a filler metal whose melting temperature is above 450 degree but below the melting point of the base metal. Here also we looked into the different types of brazing, that is torch brazing, where the two metals are joined by the heat obtained from a gas flame; furnace brazing, where the bonding in the metals are produced by using the furnace heat; dip brazing, which is used to join aluminium assemblies; resistance brazing, which is the brazing operation which uses the heat produced by the resistance of the base metals; and then induction brazing, which utilizes the alternating electromagnetic field for heating the workpieces together. Then we looked into welding. Well, welding is a process in which two or more workpieces are joined permanently to form a single component. Welding can be classified into plastic welding, where the metal parts to be joined are heated to their plastic state, and then fusion welding, where the parts to be joined are heated above their melting temperatures. Then we looked into the working of an arc welding process, where the source of heat for welding is an electric arc generated between the two electrically conducting materials, that is the workpiece and the electrode. AC or DC current is used here. When the electric supply is on, the electrode is struck to the workpiece and then separated by a small distance so as to produce an arc. This arc is made to travel along the length of the workpiece, and hence the heat will melt the joint at the two workpieces. Hence, a molten metal is formed, and upon cooling, this metal pool will fuse and hence form a single joint. Then we looked into the different electrodes which are used in the arc welding, that is the consumable electrode, which is the electrode which gets consumed during the welding process, which are further classified into coated, bare and tubular electrodes, and also non-consumable electrodes, which are the electrodes which do not get consumed in the welding process. Then we looked into the oxyacetylene welding. Here, it uses the heat energy generated from a flame, which is produced by the mixture of oxygen and acetylene gas. Well, suitable compositions of both the gases are passed and mixed in a torch, and hence then undergoes combustion, producing a flame which is used for the heat source in the welding process. A filler material is carried along with the flame, which is carried along the length of the two workpieces and hence melts both the workpieces at a joint, forming the metal pool. Once the metal pool is cooled, it solidifies and hence forms a permanent strong joint. Then we studied about the MIG welding, or the metal inert gas welding. Well, this is a welding process in which the workpieces are joined by the heat obtained from the electric arc, which is struck by a bare consumable electrode and a workpiece in an inert gas atmosphere. Here, a metal will be used as an electrode. Similarly, we saw the working of TIG welding, that is nothing but tungsten inert gas welding. Well, this is also a welding process in which the workpieces are joined by the heat obtained from the electric arc struck between the non-consumable electrode, which is made of tungsten, and the workpiece in an inert gas atmosphere. Then we moved on to the concept of belt drives. Well, belt drive is a mechanism used to transmit power or motion between two shafts by means of rotating pulleys and a conveyor belt. Well, several types of belts are used in the process. We have a flat belt, which will have a rectangular cross section and width will be more than the thickness of the belt. The V belt, which will have a trapezoidal cross section, and then a circular belt which has a circular cross section. Then we studied about the different definitions, such as the slip, which is the difference in linear speed of the pulley rim and the belt passing over it; the velocity ratio, which is the ratio of the speed of the driven pulley to the speed of the driver pulley; and then the creep, which is the relative motion between the belt and the pulley surface. Then we looked into the different types of belt drives, that is the open belt drive, in which the belt travels from the top of one pulley to the top of another pulley and both the shafts will be rotating in the same direction; and then the cross belt drive, in which the belt travels from the top of one pulley to the bottom of another pulley and hence the shafts will rotate in the opposite direction. Then we derived the expression for the length of the belt, which is used in an open belt drive and in a closed belt drive. Also, we looked into the advantages and disadvantages of the belt drive systems and also the usage of V-belt over the flat belts. Then we looked into some important formulas, that is the ratio of the flat belt tension in an open belt drive, the initial tension of the belt, and the power transmitted in a belt drive. Then we solved numericals based on the concept of belt drives. Then we moved into the concept of gear drives. Gears are nothing but tooth members which is used to transmit motion or power between two shafts. Then we looked into the types of gears, that is the spur gear where the teeth and axis of the gear is parallel to its center line, the helical gears where the teeth is cut around the periphery in a helical pattern, and then the bevel gears in which straight teeth are cut on blanks of a frustum of a cone, the worm gear which is used to connect right angle and non-coplanar shafts, and then the rack and the pinion where it is an assembly in which the rotary motion of the pinion is converted into the linear motion of the rack. Then we studied about velocity ratio, that is the ratio of the speed of the driver gear to the speed of the driven gear, and also the train value which is nothing but the reciprocal of velocity ratio. Then we looked into the different gear trains, that is the simple gear train where each gear is mounted on a separate shaft, the velocity ratio for the simple gear train, and then the compound gear train where each shaft carries 2 or more gears except the driven and driver shaft, and the velocity ratio for the compound gear train. Then we looked into the advantages and disadvantages of the gear drives over the belt drives. We finally solved some numericals based on the concept of gear drives. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.